Okay, guys, so I'm going to try to get the rest of this review in. I'm going to try to do it as quickly as I can. I already made my chart for this page, and so I filled in my X with the hits, so we know this is our X value. And then my F is going to be that frequency. That's going to be the number of games, and so I'm just going to put those over here. 29, 62, 33, 12, 3, and 1. I want to find the sum of that column, and that's going to be N equals 140. And then to find my next column, P of X, I'm just going to take 29 divided by 140, 62 divided by 140, and then continue it down. So as I did this, I arrived at 0.207. I have 0.443, 0.236, 0.086, it's 0. 0.021, and then 0.007. I want to find the sum of this column, and this is the sum of this column. Since this is the sum of the probabilities, it should always add up to 1 or pretty close to it, depending on rounding. And we see that it does. And then we want to find mu. And so when we find mu equals the sum of x times p of x. So I'm just going to multiply my x column here with my p of x column. So x times p of x. When we do this and I round to 3 decimal places, this actually just is going to be 0.000. Well, I guess I didn't even have to round it because 0 times p of x is going to be 0. But since everything else I round to 3 decimal places, I'm going to keep that at 3 decimal places. We have 4, 4, 3. We have 4, 7. I think it's a 4, but it could be a 1. Sorry, I'm looking at my old work. 2, 5, 7. 0.086. And then 0.036. We find the sum of this column, so we just add it up. That's what the summation sign here tells us. And when we add those up, we see that it's 1.293. So that's going to be our mu value. Now we take our x column. So it's at 0, 1, 2, 3, 4, 5. And we're going to take those values and we're going to subtract mu from it. So that's at 1.293. And when we do that, we end up with negative 1.293, negative 0.293, 0.707, 1.707, 2.707, and 3.707. And then we want to square that column. So we're just literally taking the column we just did. We're going to just square it. And we get 1.672, 0.086, 0.500, 2.914, and then 7.328, and 13.742. And then we take that column, the one we just did, the x minus mu squared, and we multiply it by p of x. And that's our final column. So over here, we do that, we get 346.038, 0.118, 0.250, 0.157, and then 0.098. We're interested in the sum of this column, which is going to be the x minus mu squared times p of x. And so that's a whole thing here. When we add up that column, we end up with 1.007. So now we want to find mu and graph. So let's do our graphing first. Again, I'm struggling on here, so hopefully I'll be able to get this okay. So hits per game. And then over here we have probability. And then down here we have hits. Okay, when we go up on these, you guys kind of change as you need it. I understand that some of our numbers could be small, but we still want to stay pretty consistent with our scale. So 0.10, 0.15, 0.20, 0.25, and our biggest number is going to be a little shy of 0.45, so I've got to keep going. So my scale for me is probably not my best, but it's only because the way I drew it. So 0.3, 0.35, 0.4, 0.45. Now that we have that, we're going to now make our bar graph. So our first probability is 0.207. So over here I have 0, 1, 2, 3, 4, 5. So ideally you'd be using a ruler, but I don't have one of those on here, so we have 0.207, so right about here. Then we have 0.443. We have 2, which is going to be 0.236. So right in here. 3 is going to be 0.08. So we're right in here. And then 4 is going to be 0.02. That's pretty small. And our last one here is going to be 0.001. So I'm just going to draw like that. So now that we have that, we at least have our histogram. And then our last spot over here, we're going to find mu. Mu equals, it's a terrible mu. So mu equals the sum of x times p of x. We already found this, and this was 1.3. And then we had sigma squared, or our variance. That's going to be that x minus mu quantity squared, p of x. And we found that up here. And so we see that's going to be 1.0. And then sigma squared, or sigma, is the square root of sigma squared. So it equals the square root of sigma squared, which is equal to the square root of 1.0, which is 1. Okay, so that is how we do question number 22. We already did 23 on our last page, and I believe I did 24 as well. I do not remember if we did 25, so I will redo 25 in the case we didn't do it. Okay, so 25, we want to identify some values. First off is we are interested in adults, n is 8, and then we want exactly that one of them is on a diet. So probability 1 in 4 is on a diet, so 0.25. So probability of exactly 3 equals 8 choose 3. So this is just using that binomial formula, chance of success to how many successes we want, and then chance of failure. And then remember, this is going to be 8 minus the success is what's going to be a failure. That's 0.208. At least 3. We can write that out as px is greater than or equal to 3, because at least means that that's going to be the lowest number. That's the same as 1 minus the probability that x is less than 3. So I wrote this out as 1 minus probability of 0 plus the probability of 1 plus the probability of 2. So I'm using the complement to find the probability I want. So since I want everything that's 3 or greater, I could do 3, 4, 5, 6, 7, 8, or I could just know that everything that's not in that is what I can find. So I found 0, 1, and 2, and I subtracted that from 1, then that's going to be the probability I'm looking for. So this works out to being 1 minus 0.100 plus 0.267 plus 0.311. This is going to give me 0.322. And then the last one is more than 3. So p of x is greater than 3. That's the same thing as 1 minus the probability that x is less than or equal to 3, which is equal to 1 minus, and again, it very similar to the last one, but now we don't want 3 included, so we want the probability That's 0 plus probability of 1 plus the probability of 2 plus the probability of 3. And then here I have 1 minus 0.100 plus 0.267 plus 0.311 plus 0.208. And when we perform this, we see that's 0.114. So again, we're using the fact that we can find the complement to not have to do as many steps in solving. We're on to the last 2 pages. Okay, so the next one says 63% of adults in the U.S. rent videotapes or DVDs at least once a month. Consider the random variable that 5 Americans who were asked if they rent at least one videotape. So they told us again this is going to be that binomial distribution. So I just made a nice little x, p of x, and then I went through finding them using what we know of the binomial distribution formula. So that is going to be your, here we have n equals 5, p equals 0.63, q equals 0.37. So we have 5 choose x, then we have 0.63 x, 0.37 5 minus x, where x is going to be our values over here. So we have 1, 2, 3, 4, 5. So just running this pretty quickly, I was able to get 0.059 or 0.201, 0.342, 0.291, 0.099, and again we can add these up to make sure they're close to 1. Then we're just going to graph using a histogram. So we're going to be 0.05, 0.10, 0.15. This time I don't have to go up as high, just 0.35, 0.20, 0.25, 0.3, 0.35. And then this is renting movies. This is probabilities. Down here we have Americans. Zero, 1, 2, 3, 4, 5. Okay, now we're going to graph. So that 0.07 is going to be pretty small. So we're going to go over here. So it's going to be pretty small down here. And then the 1 is going to be 0.059. So, and then 0.2 is going to be 0.02. That's nice. And we're here, just a little bit above that 0.2. And then 0.34, so almost all the way to the top. And then, oh, sorry about that. So now we're going to come back and we're just going to finish this up. And so we now have 0.4, and 4 goes to just shy of 30. And last one is 5, and that's just going to be shy of 0.1. Okay, and then our last part is mu equals NP, which equals 5 times 0.63 equals 3.2 equals NPQ, 5 times 0.63 times 3.7, which equals 1.2. And then sigma, that's sigma squared. This is going to be sigma, which equals the square root of sigma squared to the square root of 1.2, which is approximately 1.1. Okay, so number 27, note 27. In a recent year, 40% of trucks sold by a company had diesel engines. Consider the random sample of 4 trucks sold by the company. Again, we see that we have N equals 4. And then P is going to be that 40%, so 0.04. Q is going to be 0.60. So using that same fact, we can set this up as 4 choose X, 0.4 X, Q, which is that 0.6 to the 4 minus X. Create a quick table. X, P of X. 0, 1, 2, 3, 4, 0.132, or 0.30, 0.346, 0.346, 0.154, 0.026, and again we got all of these by using this formula over here. I can even put as the probability of X equals, and then you're just going to continue substituting in the X value that we're looking for. We're going to use a histogram again. This one only needs to go to 0.35, so 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35. And hopefully yours looks a little nicer. I'm just trying to get through this quickly. 0, 1, 2, 3, 4. That's all I need. Okay, and then now we have, these are probabilities, so probs. And down here, trucks, diesel engines, okay, and now using this, we're just going to graph that again. So 0.13, it's going to come right up in here. 1 is going to be 0.34, so that's pretty high up. And 2 is going to be the exact same. Sorry, guys. 3 is going to be 0.15, and then I'll scoop 4 over, and we see that 4 is going to be 0.26. Okay, so it's a little bit rough, but that's what our graph should look like. And then the last part again is finding mu equals NP, which equals 4.40, which is approximately 1.6. You're using that sigma squared. So that's our variance, NPQ, which equals 4 times 0.40 times 0.60, which equals 1. And then once again, standard deviation, which is the square root of that variance, which is the square root of 1, which we know the square root of 1 is just 1. So we have our 3 answers here. Last page, yay! Okay, so on this one, we are now using a geometric distribution. So if we're looking at this, you're buying soft drinks each day. We have the probability of X being successful being 1/6. So we can actually just write that as P equals 1/6. P equals 1/6. That means Q is every other day is not, so not every other day, but 1 in every 6 winners. So the one that's not a winner is going to be a loser. So 5/6. And then, so the first one is we want to find on the 4th day, assuming that you're only buying 1 a day. So we're going to get that by 1 over times 5/6 times 4 minus 1, which is approximately 0.09645, and I rounded that to 0.06. Okay. So again, that's just using that formula that we use is P times Q to the X minus 1. Up to the side at this point, I knew that I wanted to find within 4 days. So X is less than or equal to 4 because 4 is my last day. So this is the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4, which is approximately, and I did my work off to the side. So I have P of 1 equals 1.656. 1 minus 1, which equals 0.166. Over here we have P of 2. Again, we only want our first success to be on the second day. So that's what this one's asking. So we have 5.6, 2 minus 1, which is equal to 0.1389. And the probability of 3 equals 1/6 times 5 or 6. And then again, that is happening on the third day. So you have 1 success, 2 failures, or 1 failure. No, 1 success, and that results in 2 failures. And then we have 0.11574. I can't fit the 4 in. And then the last one is P of 4, which is 1/6. So you had a success, and that means you had 3 failures. That's 4 minus 1, which is 0.0964. So for question B, we add all of those together, and when we do, we get 5.18. Okay, then this one says sometime after day 3. So sometime after day 3, we are interested in finding that value, and we know that we're in a contest is going on. So what we're going to do is we're going to take the probability that x is greater than 3. Now we could calculate 3, 4, and then continue on, or we can do the complement. So 1 minus that complement, which is that probability that x is less than or equal to 3, which is equal to 1 minus the probability of 1 plus the probability of 2 plus the probability of 3. And we get that as 1, and then we already did this math to the side, so this is why we did this one. It's a little more convenient. 666 plus 1389 plus 0.1157. And when we do all of this, we end up with 0.5789. Nope. I have a 7. That's a 5. That's a 7. I'm sorry that this got messy, but I'm just trying to make sure we get done in time. Okay. Last but not least, this one is our Poisson distribution. So on my page, I wrote off to the side, P of x equals mu to the x, e the negative mu, all over x factorial. So the first part is we have to find mu. So we know that 2,457 people are killed in 36 years. So if we're looking per year, we have 2,457 divided by 36 years, and that gets me 68.25 people per year. Lightning deaths per year. But that's not really what I'm interested in. I want to know how many are per day. So 68.25, and we have 365 days in a year, which gives me 0.1869 deaths per day. Cheery, right? Okay, and then now we want to find the probability that no one will be killed by lightning. So that's the probability of 0. And so I'm going to take that, and I'm just going to now substitute in what we know. So my mu is that 0.1869. I'm going to erase that lightning deaths per year part right here so I have space. I can change color as well. 869. And that's going to be raised to the 0 power. Then we have e to the 0.1869. And this one is going to be negative, because remember it's a negative mu, all over 0 factorial, which gives me 0.830. And then down here, probability 1, 0.1869 to the 1, e to the 0.1869, all over 1 factorial. That's 0.155. And the probability that x is greater than 1 equals 1 minus the probability 0 plus the probability of 1. So that more than one person, so that's the probability of nobody, and then 1. And so calculating those two, we already did them above. It's going to give me 1 minus 0.830 plus 0.155, which equals 0.015. Okay, good luck, guys. Let me know if you have any questions.